Gentlemen and ladies, once again, happy Wednesday to everyone, and thank you so much for participating into this ISET Robotics M2 session. I hope you are going to enjoy the session. For those of you who are watching this recording, you are welcome, and you came at the right place, at the right time, in the right platform, with the right people, with a very great presenter. Otherwise, without wasting any further time or moments, I'll hand over to Meneer Johannes for the house rules.
Thank you so much, Tamilo. Yeah, like you said, we have only a little bit of time and only so much electricity, so I'll be quick. So we only have a few house rules. We would like to ask everyone to please mute your cameras to save data and bandwidth. Also to mute your microphones, keep all the background noise to minimum. If anybody has a question at any point in time, please feel free to raise your hand, or if you have some mic problems, please put them into the chat area. And like I said, we have not so much time, so over to you, Dr. Gous.
Morning. Oh, no, it's not morning. It's afternoon. Oh, my goodness. All right. I just need to fetch something here quickly.
While on that note, please don't hesitate to have a look at our chat box, whereby you will see information regarding the session. There you go. I see Caspar has handed it over. So if you would like to find out more about us or have any questions regarding today's session or any other session, there's the email address there. And then we also have a social media page on Facebook, Twitter, as well as YouTube. For those of you who would like to get our recordings are available at the MOOC portal, and we post them there at the MOOC portal because it's 0 rated. Otherwise, over to you, Dr. Gous.
Yeah, that was a good introduction there, Tamila. Well done.
Thank you.
Oh, exactly. All right, so today we're going to do something a little bit different. So remember us kind of when we started. Oh, so we're past halfway already. So we're in session number 3 already. When we did M1, we just did the basic robot, basic programming, and navigation without any sensors. And that is a good foundation. You need to be able to do that. All right. And then we did some problem solving there. When we come up to M2, you know, there's an M3 and we keep going. But on M2, we've now added, we've done 2 things. We've added the sensors and we've done flow control. So that is where the programming increases a level, because now we are taking data from the environment and we're using it in our robot to make the robot, in brackets, cleverer. Okay, so it'll stop before it collides with a wall. It'll detect an item in front of it. It will reverse and only reverse into the wall. It'll stop. And so all these things add to the programming of your robot. You're using data and you are using different control structures. Okay, so what we're doing now is we are going to just park the programming part, and now we are going to do the structures. Okay, and for the structures, to improve the structures, we're adding a thing called gears. Now, gears are not just little things like this with teeth, you know, with teeth like that, where they go together and they mesh. We know that, all right? But you have to be able to effectively use gearing in your robot, and we were now focusing on structure. Okay, so instead of a robot just moving forwards and backwards, it actually can move forward, grab something, and move backwards. Or it can move forward, drop something, or pick something up and move backwards. All right, so you see we are now adding structure. So this is old Mozart. Mozart has got you can see the motor here, and the motor has got an arm on it. So this thing goes up and down, so we can program this motor to let the arm go up and down. Okay, but the arm, the powered attachment that we're going to program, is controlled by gears. I don't know if you can see these gears over here. All right, and so on the so on, oh no, here we go, down here. So on the motor itself, there's through the motor there's an axle. There we go. and then there is a driver gear, and the driver gear and the larger gear are on the same axle. And that is what today is all about. Okay, so we're doing gearing and we're doing power attachments together, because gearing is applied in power attachments. Okay, so, and what does gearing do? Gearing, so with gearing, you've always got a trade-off. Okay, you either have speed or you have power. Okay, and that's what we use gearing for. And it's like a car. If you're in first gear, all right, you have much power, but you don't have that much speed. All right, by the time you get to fifth gear, you're going to sickle to go up a hill, but you have speed on the flats. Okay, so there's always that. So with gearing, you've got a rotation or you've got a movement, and you can use gearing to increase it, decrease it, change its direction. Okay, and I'm going to go through it. So the gears of a robotics kit are always lots of fun. Okay, so you get these things and you think, oh, this is a lot of fun. It'll make a real cool designer. But this is the rack from the rack and pinion. And then my favorite is the worm gears, and I can't find my worm gears in here. And I have to go and look for them. Okay, so that's where we are. We're going to do some gearing. Again, you can get away with building a robot without gears. You can get away with a robot with only passive attachments. But you want the learners to take the next level. And so all those teams that are doing second gear already with competitions, you need to up your game. All right. And so there's always that ongoing learning of increasing complexity. One of the best gearing mechanisms is the dog gear mechanism. It's a whole mechanism. And what dog gears are used for, let me give you an example over here. Oopsie daisy. So what dog gears are used for is, you can see on Mario, there's these two knob gears over here. But these knob gears are actually, can you see? You can't really see inside here. Okay, inside here, the knob gears are attached to two medium motors. Okay, which means that you can then attach powered attachments onto here, and then the motion is transferred through this gearing mechanism. Okay, so your powered attachment is attached onto the robot, and then the power part comes through here. So you can use multiple powered attachments on these two parts, and that is where also for powered attachments you must have a motor that you can program. All right, we're good. All right, so let's quickly go through the presentation. Everybody, okay, this is my little, can you see my screen? There we go. Okay, slideshow and from the beginning. All good?
Yes, Dr. Harris, I see it from my side, yes.
Excellent, thank you so much. Okay, so we've got gears and powered attachments. It's quite a hectic combination, but you must know it's all in the realm of increasing the efficiency and effectiveness of your robot structure. Okay, so that's my navigation again, and we're assuming you finished robotics M1, but if you haven't, it's fine. I mean, you can come and spend the afternoon with us as often as you like. It'll be awesome. All right. Yeah, we're on session number 3 already, so let's just keep going. And okay, so this is the after basics. You've done the basics, then you've got next, and the focus is going to be powered attachments. So we build and program powered attachments. But before you can do that, you need to know about gearing. You need to know how to build gears and how to program gears. And I want to ask you that if you look in the overview, the M2 overview document, try to build some of those gearing mechanisms, and then just to attach it maybe to a motor and see whether it'll work. All right. Okay. So for unit A, there's an A and a B part. The one is the gearing models, and you've got to write the programs to get those to control those gears. And the next part is the powered attachments, hopefully using those gears. Okay, so you build a model and then you write the program, but it's important to test every combination, because otherwise your learners are going to like, I can do this, but they can't actually because they haven't built it. All right, so a gear is any machine part that rotates. It's usually got teeth with mesh that mesh within the teeth of another gear. And why do you use gears? Well, there's speed, there's torque, and there's direction of power source. So some of the gears are used to make rotational movement linear, and that would be, for example, your rack and pinion. Some would be to change direction, maybe for a bevel gear, where it changes direction of 90 degrees. Okay. So, and I'll show you some examples. There's lots of really cool little gears in your robotics kit. Okay. So, for example, the rack and pinion. That is the pinion. This is the rack that moves, and the axle at the back there, that's the one that's attached to the large motor. Okay. Building gear trains is a lot of fun. If you attach that axle that goes through the driver, to a motor and see what happens, and then you try put the axle to the larger gear as the driver, and then you see what happens and how many times does one turn and how many times does it not turn. Okay, I'm actually going to show you an example quickly. And then to transfer movement, you always like the bevel gear that goes the 90 degrees. Okay, so they're meshing at 90 degrees. So these are the examples. The spur gear is kind of the normal little round gear. The crown gear kind of sticks up in the sky, and the bevel gear is at 90 degrees. Okay, you sometimes get double bevels. Yeah, the worm gear is one of my favorites, and the clutch you don't use that often, but if you do use it, your learners have to know how to use it. All right. The knob gear, I think, is the most popular one. And it's one of those gears that you can use, and as soon as you use it, it gets confidence. Your learners can say, "Oh, we can do gearing. We're good." Okay. That's a really cool little gearing thing there. Okay. When you build a gear train, you've got to have a driver, and then you've got to have a driven gear. But the little idle in the center, the learners have got to register that the one is moving in one direction, and the other one is moving in the other direction, the opposite direction. And then so every second one moves in the same direction. The rack and pinion, you've got to know the pinion is the one that you attach to the motor. Okay, so if you're going to make the pinion rotate, all right, then the rack will move left to right. Okay. But if you don't play around with it, then the learner's not going to get it. You can show them as many pictures as you like and little arrows, but they actually have to do it. So I would say have a really good gearing class just to explore the gears. Okay. If you're doing programming, so this would be programming. You attach a motor, say motor A, and you let it run for, say, 10 seconds, and you'll see what happens. All right. That's just if you have a spur gear, then there's no restriction on that. Okay. But then change the powers and say, okay, so why don't we make it 50% power or 100% power or something? And then we'll see what happens. And then the learners must be able to explain to you what is the best gearing speed, okay, or power setting. And the same is with the bevel gear. The bevel gear is at 90 degrees, and you can run the code. It looks very nice and neat, but if you turn it too fast, well, maybe it's going to just not be great. All right. So let the learners do it at 20 degree, at 20% power, 50% power, 100% power, and then to tell you what the impact is. Okay. So now you've got I'll show you some examples as well of different gearing structures that we have, but I'll show you that now. The problem with powered attachments is they must be well built, otherwise they are a total disaster. Okay, so and the other one, let me just quickly say, if you have a powered gear, you must have a motor. You can use gears in brackets, but it requires programming to function. Okay, if you use powered attachments, please always program with time. Please program with time. I'll show you now an example. Okay. So when you have a powered attachment, where do you attach it? Well, that depends where you need it. Okay. If you need to pick up something in front as you're going along, maybe in front, in the center, at the back. But a powered attachment can be attached wherever it is needed. Okay. But here's the kicker. It must be attached as a structure, and it must be connected with wire for function. Okay. Otherwise, it's not going to work. It needs structure and it needs function. All right. So, so what I want to say is that powered attachments, you need to start building a frame of reference for your learners. Okay. the Riley rover has got two really cool powered attachments. The one is up here. So this is the cargo loader. Okay, this is the cargo loader, and this one is then the grabber. Okay, so the cargo loader moves up and down. Can you see there? And the grabber moves, oopsie, moves left to right. Okay, and grab something. All right. So you can grab, you can lift, you can push. But, and I say it again, let your learners first build these powered attachments from building instructions. And then you change. All right. Then you modify. Then you say, okay, so that one can lift something up, but it might fall through there. So we adapt that. This one could grab maybe I don't know, an apple, but maybe it's too heavy. It's not going to be sufficient to grab a tin of condensed milk. Okay. So the powered attachments is grab, lift, and push. But it can be multi-purpose. Okay. So the same grabber can go forward, collect, and reverse, or it can go hold something, move forward, and deliver. Okay, so already we have two purposes for one attachment. All right, exactly the same as that. This one here with the cargo loader. So you can leave base with something in your attachment, and you go forward, and you can drop it, or you can go forward and pick it up. Okay, but here's now the really cool part. If you turn that attachment around, same attachment, you've got now a multi-purpose attachment. And I'll share a really cool link now. Okay, so there we've got the gripper, and there we've got the cargo loader. All right, two really cool powered attachments. Okay, both are connected. You connect the motor to port A. So A and D are all the attachments, and B and C are the motors to make the robot move. Okay. So over here, if you've got the gripper, there you've got your spur gears, and there you've got a worm gear attached to your medium motor. Okay. If the gripper is modified, well, if you can modify your arms, make your arms bigger, make your arms smaller, shorter, longer, stronger. My biggest modifications, I would put little rubber. You get those little rubber connectors at the ends just to hold something better. All right. The cargo delivery has a knob gear meshed, so you can see it over there. Okay, and so this lifts up and down, moves the arm up and down. But if it's turned the other way around, it can go forward, come down, and pull something backwards. All right. So just as a picture here, this is your arm going up. Okay. So for the cargo delivery, if you see here, there are your knob gears. Okay. And then the arm can go up and down. So it's in front of the robot, going up and coming down. All right. But if you want to carry a bigger thing, a bigger object, you might need to make it longer. All right. You might need to have sides on it. So that is where the structure changes. All right. So how about this one? This one is then your gripper. You will see that over here. Where's my mouse? There we go. You must make sure that that axle is free to turn. Okay, so before you even put the spur gears on, just let the robot's motor rotate like, I don't know, 2 rotations, just to make sure that worm gear is actually turning. And if it's turning, then you put your 2 spur gears. There's your meshing with your 2 spur gears there on the other side. Okay, and they're obviously moving, and then they're controlling them. Let me just go back here. So linked. So as this thing turns, this arm that's linked to a little axle or a connector, that turns. And as these turn this way, round and round and round, this arm will come in and go out. Okay. Right. So for every attachment, you build the powered attachment, attach it to the robot, and then you write a program to function it. You've got to do all these steps to make sure that your learners have got in their heads how a powered attachment works. All right. But please control the powered attachment by time, and I'm going to show you now exactly why. Okay. So a good idea before you even start is to test whether your powered attachments is going to go up and down. So you have a starting position, all right, and then you let it rotate for 1 second. Okay, and then if it goes up, then you say, oh great. So if it's positive, it goes up. So negative, so minus 20%, minus 20 power will make it go down. Okay, so then you can make it up. But put, okay, so number one, you must have a comment. Just put in a comment to know what you're doing. And there must be a weight. You can't go up, down. So you go down or you come up, then you wait for 1 second and change down. Good habits to get into when you're programming. Okay, so if up is positive, then down is negative. And you think of this as a task, must move forward, drop something. So if you have this as an example, you say, there's the positive, so it goes up. All right, then we're going to quickly load something onto the loader. Then we're going to drive forward for 2 rotations because it's B and C. Then we're going to wait for 1 second. And then A is going to drop something because it's minus 20. So the arm is going to go down. Okay, and then it must drop something. And then you can carry on programming and then maybe reverse back to base. All right. So with whatever you're doing, it is very important that what you do, if you go up, you go down. If you open, you close. Whatever you do, oh, maybe I went a little bit faster. Wait, I know. Okay, so you must have a starting position. I'll demonstrate this now. You must test whether positive is up or down or open or closed, all right? And you must always control it with time, okay? The bad thing with a gripper is that the arms cannot cross over. Okay, so if they come together and they cross over, then you've programmed too much. But if they don't touch, they might be too short. At some stage, you must have the arm that they can actually grip something. If it's a gripper, it must be able to grip. Okay, you might need to modify the structure. Okay. So what I want you to do is when you do powered attachments, build the powered attachments and then program it. Okay, and then you add it to your robot and say, okay, how are we going to use this? Go forward, drop something, pick something up. Okay, and then you try with additional items, but you must evaluate the efficiency of your robot. You need to have an evaluation. Please don't let the learners just assume they know what they're doing. They need to be able to justify why they've got the powered attachment, how they've used the powered attachment, whether they can modify it. Okay. Yeah, right. So in terms of gearing, there's a lot of really cool little videos. The dog gears, Builder Dude 35 does a good job of that. But there's different types of gears, and it kind of depends on how much time you want to spend on your gearing, because now you're assuming your learners are going to apply it. Okay, so maybe think about that one. The whole thing of gearing and powered attachments. I've got the Winning Design book. This is for EB3. They haven't brought out the design patterns yet for Spike, but this is a really cool recommended reference. Sorry, reference to have, and I've learned a lot from this guy. All right. Okay, so for Unit 2, you've got 2 quizzes. You can do one or both, or you only need one of them for the assessment, and then you can talk to us. All right. And I think that's the end of that one. Let me just quickly stop sharing here. All right. So if I can share with you, why do you use time? Is that this arm goes up and down, and so you say, okay, my starting position is this. Okay, your arm is vertically up. Okay, and then your robot's got to do. You program your arm to go 1 rotation. Now your arm is going to come down to here, and it can't complete the rotation. Okay, it's going to just keep here, keep pushing. This arm's going to come down and it's going to keep pushing on this because it can't do this. So even if you say, okay, so only half a rotation, but if your arm is slightly not, let me just put it up. So maybe other way. So that will be half a rotation, you think. Okay, more or less. Okay. But if you don't have the same starting position, your robot is going to not be able to complete the rotations. However, your saving grace when you do powered attachments is if you program for time and your robot arm comes down. Oh, I don't like this noise, but I just want to demonstrate. If your robot comes down and it touches here and it hasn't completed the rotations and it's programmed on time, time passes. Okay, so if you've programmed to come down for 2 seconds, it'll come down for 2 seconds and then it will carry on. Okay, time and time again, I see teams that have programmed their powered attachments on rotations. In the competition, they forget to check their starting positions, or they're just very flustered, or they don't check it, whatever the reason is. And then another mission that the robot can't do. Please program your powered attachments on time. Okay, that is my 2 cents worth when you do powered attachments. Okay, really cool to learn different mechanisms. Really cool to go through different ways of doing powered attachments. And now I'm trying to think where that link is, and there's a video from Dr. Hino, and he says where nearly all missions, and I think he's done it for City Shaper Challenge, and he's done it for, I know he's done it for Into Orbit. The Into Orbit Challenge and the City Shaper Challenge, Dr. Hino showed that you could use just the Riley rover by modifying those 2 powered attachments, just the gripper and the cargo loader. And just those 2 attachments, you can do most of the missions by modifying 2 simple powered attachments. Obviously, if your team is 2nd year or 3rd year, they're going to learn different powered attachments. But for any 1st year team, learning to modify existing powered attachments is a good place to start. Absolutely. All right. Are there any questions? Any questions? Any comments? And our power has just gone out. Okay. Anybody?
If anyone has a question, you can unmute.
Anybody?
May I ask a quick question?
Hi, Jackie. Yes.
Hello. In the process of the X amount of weeks before we get to a challenge competition,
yes,
where do you envisage including this kind of lesson? Because I know the challenge does sort of get, the lesson, the weekly training gets progressively.
yes.
Do you sort of stop the process and say, right, today we're going to, the kids have got to a stage now where they I can see they're playing with gears and they're wanting to do it, and consciously teach a session on gears like you've just done now, and then we carry on.
Yeah. So the 12 sessions for the challenge can be divided into 3 stages of 4 lessons. Okay.
Yeah. Okay.
So your first 4 is kind of unpacking everything.
And setting,
the next 4 is kind of fitting it all together, and the last is like really fine tuning it. Okay.
Yeah. Okay.
But in the first 4, where you're busy putting all the pieces together. Okay. So what? Maybe I'll do that next week, tomorrow.
So it doesn't have to be without a gap. It's not like we start from week 1, we get to week, because it makes it easier for me, because to do it that way, to section it, because we've done our first hour, we're on 3rd week, 1 to 3 weeks.
Yeah.
So after next week, I would like to almost do a team training session to do, but that doesn't necessarily go on to lesson or the team meeting 5, and that is fine. Is that okay then?
Yeah. So what normally happens is, if you are faced with a challenge, so you've done your basic, the robot, the learners know how to do navigation, how to move the robot and everything. And so that one of the steps where you have a team brainstorming is you take all the missions on a challenge and say, oh my goodness. And sometimes it's easier to say to the learners, pick 2. Pick 2. One must be really easy, and the other one must be a little bit more difficult. And so so if I have normally I have a team of about 8 learners, and then I've divided them into teams. 3 sets of 3, more or less. Okay. And so each set of 3 must take ownership of 2 missions. Okay. That means they have to really think through 2 missions. One must be easy, guaranteed, and the other one is a bit more out there. And so they've got for both missions, they've got to but in a team brainstorm. All right, is this? And then it's the verbs. It's like push, pull, grab, drop. What is the verb? Okay. So the push ones, the push you can do with a passive attachment. The pull ones, you might be able to get away with the passive attachment, but you might need to just use the cargo loader to go fetch it. And then when they go like this, ma'am, we got to do something like this, then you can say, okay, let's use the cargo loader. Let me teach you about the cargo loader.
Okay.
All right. All right. So the really cool thing is, then they get to say like, oh, we don't know how to do this. Okay, then maybe we need to get attachment for something like this. And then you can maybe just say pause and say for half an hour, say, I'm going to teach you something really cool about gearing. Okay. And kind of in the natural flow of it. Then they've got it, then they've already got the easy points developed. So they for this challenge, let me lay out the table tomorrow and then I'll show you. So there are some easy missions, and it's usually half like this, half of the mat. And it's usually just a push mission, something that you can push, and you can get your guaranteed points. Now, when they've got they've got a mission that they can do, and they've got the guaranteed points. Mm-hmm. Now they come with this more difficult one. Like last year was on the replay, there was that thing that they have to balance on the crossbeam.
Okay.
Now then your learners will say, ma'am, it's got to go up and it's got a hook on there. Then you can go and say, okay, number one, that is a powered attachment, all right? But it's got to be far in the front or in the middle, and it's got to lift the entire weight of the robot. So then you've got to think, okay, where is your center of gravity? Because I'll show you. So that was one reason why we modified this robot to be not long like this, but long like that. Okay.
Yeah.
Okay. So that that distance is shorter. So when you pick it up, then that distance can be picked up.
Okay.
Yeah.
Look, at the moment they're just trying to build small and fast, so they haven't figured out that it's, that there's other things they need to do.
Yes. Jackie, you've got a rookie team. Okay. Let them celebrate what they can get right.
Yeah.
And that is the cool thing about developing, and it's not a hit and run thing. I've been working with the kids that built this. I've been working with them for 9 years.
Okay.
No, this team was they were a team since 2013. Yeah, it's 8 years. Oh, well, it's 8 years. Yeah. Yeah. So and I'll show you another example. So this is Angel. I said angels, but look at their complex structure. All right. So they needed. So we went from normal robot. Everybody did winning design. Winning design's got the frame around it. Okay. Yes. And I insist. It's once you've moved up from Riley Rover, you do need to build a frame for me, especially if you get a heavier robot. But for the Nature's Fury challenge, we needed a flatter robot. It was all my days. There was a wire, there was a rope or a string across the whole challenge mat on which a helicopter was hanging or a plane was hanging. Okay.
Okay.
If you go and look at Nature's Fury, it was all my days. Okay. So this robot needed to be flatter. It's still got the frame. Okay. So it's got the frame that I wanted. But you see here, the motors are under the brain.
Yeah.
And after sessions, we figured out that we actually need to put the motors next to the brain.
Okay.
Because we needed an overall flatter robot. It needed to pass underneath the wire. Yeah. So that is where you have the basics. You get your teams or each of the groups to do one mission that they can definitely score points, and then you start interrogating the more difficult things.
Okay.
And that will probably be in the middle 4 weeks. So you've got 4 weeks where you like strategize. We've got something that moves straight forward, and you get your guaranteed points. That is where you do passive attachments.
Yeah. Okay? All right.
Passive attachments. The middle part will be like, oh, now we're going to move up a level, and now we start getting. So your gearing, and your power attachments, you'll probably introduce in your middle 4 weeks.
And just one little short question on that. Then, with a team of 10, where we've already started identifying, the kids have started identifying amongst themselves who the coders and programmers are. Do I spend time on those small, because we have one robot. Do I concentrate on the builders and because the other kids are doing the innovation projects, or do we teach it? I wanted everybody to have the opportunity, though.
Everybody. So you take your 10 learners and you divide them up into, say, 3 groups. All right.
Okay.
Where each group has a builder, a programmer, and a researcher. Builder, programmer, researcher. Builder, programmer, researcher. Okay. And within that group, and I suppose that's what we've kind of lost because we haven't got in-person events at the moment, but we're going to get to that. So that group of learners brings the robot, and for that mission they run. So they build the attachment, they run the program, they have saved the program, but that is their contribution to the team. All right. Okay. And I really caution that you do not identify, you're the builders, you're the programmers, and you are the researchers. I have seen it at international events where they have crucified the little boy that was the programmer.
Ouch. Yeah.
It's far too much responsibility for a child. And if each group have got their missions, then the sum total of all the missions will make the total score. Okay. But if you have, and you're in a little group, you'll have the programmer, the builder, and the researcher, and then they will collaboratively come and do things. They will tend towards roles, but never have one programmer and one builder in a team. You might get some learners that want to build the chassis, then let them build just the structure, the basic robot. And then you might get some that really fiddle to how to do this attachment and modify it and to build it. I've got a bucket of attachments. Yes, I have got a bucket of attachments. I'll show you different attachments. Some learners like to build very complex attachments, and some they can get it right with a smaller attachment. It's good.
That's just where I'm backing at the moment, is with my group of 10 with the one robot, to make sure I'm exposing all of them to an equal amount of access to the building and the programming as much as everything else. So I'll work it out, but okay.
So maybe we can discuss it also tomorrow. So another thing that you can do is we run scorecards. You run scorecards at the end of every session. But what you can do, and I'll have tabulated things. So you have a table. So mission 1 is A, B, and C, and mission 2 and mission 3, and then we'll group them together. I have one learner who likes timing and scoring robots. Okay, so then you time and score each of the missions. All right. The cool thing about that part is that when you come to your last 4 weeks, you can say, if we run this mission, and then this is where strategy comes in. This mission, and then that mission, and that mission, we will score 50 points. It'll take us, say, 100 seconds. Now we have 50 seconds left. Of all the other missions that we have completed, which mission should we try? Okay. And so you probably go to a competition with more missions solved than what you can run in 150 seconds. But you can always use that to wow the judges.
Yeah. All right. I don't seem very confident. We'll get there.
Yeah. And you have a strategy. You have a strategy. You must always, just by the way, you must always have a program that just says reverse. So your robot will just clear. So excellent. I have, it's called an emergency clearing. So sometimes if you know there's a little risk that something might get dropped, then you have a mission that says just clear, and
just run that one. Okay. Yeah. Thank you. Thanks.
But you know what? Also, maybe we should have a session like halfway through the season and say, show us what you've got. Show us what your robot does. I have Mario, this little robot here, used to perform best when the song Mario used to play on the PA system.
Love it. Yeah.
I don't know how true it is, but that's what it did. And it scored the most amazing points. And so, it was just one of those things.
Excellent. Thank you.
Lots of fun. Yes. it all fits in together eventually. But there is, and I suppose that's where coaching comes in, is that you are able to guide them, that they mustn't panic to say, oh, we haven't got any missions. So the first 4 weeks really used to unpack all the missions and see what you're going to do, what is easy, what is difficult, have lots of discussions. And then the middle 4 weeks, you're kind of starting to pull everything together. Okay.
Good. All right. Thank you.
Thank you. Sure. All right. Thanks for that, Jackie. I know Jenny, you're starting with a challenge, so we're gonna go slow, but we're gonna get there. All right. It's gonna be lots of fun. And I also think maybe you can do just one mission. Let's see whether we can do one mission. What's the first mission you can do? I'll share with you a video. I'll see whether I can find it tomorrow. And I'm going to maybe close with this. So my very first team, at our very first competition, it's called Smart Moves, and there's a bridge. And to get up the bridge takes 16 seconds. All right. But our robot can only, and our team was like, yes, man, we're going to do this. We're going to get up this bridge. But you can only go up the bridge if we had removed our color sensors. Okay. So in the video, you can see the two, Nicholas and I think Brandon was standing at the table, and they look around to the timer and it says 20 seconds. And so they know that if they can take off the color sensors in 4 seconds and start the robot, we can get up the bridge. So we've got to go down and get up the bridge. I kid you not. We get up the bridge with 1 second, And we didn't go far up the bridge. We went that much off the bridge, but we were off the bridge and we scored those points. That was a high risk mission. And the boys knew we needed 20 seconds to do it. And their risk taking paid off. But I'll show you the video. It's sometimes you've got to take risk, and sometimes the adrenaline is amazing. And sometimes your robots behave. Okay. Whew, that was good. All right. Anybody got anything else to share? Are we good? We're all good. All right. Let's have a look. Oh, Cabello, you've got power again. Would you like to close the session for us? Seeing that Tomelo is load shedding.
I'll just.
Cabello, your voice. Oh,
for those questions that I keep on coming, because hello.
Oh, we can hear you. Yes, cool.
Yes, I was saying we'd like to thank you everyone for attending, and to say that we appreciate your presence here. And I only attended the last few minutes, and we say thank you until we meet each other tomorrow. Thanks.
Absolutely. Absolutely. All right. Thank you, everybody. It was a really cool session, and let's continue the conversation tomorrow. Thank you. Thanks, Cabello. Bye, Danero.
Thank you.
Bye.